Hello students, today we are going to start a new problem from the topic details to assembly drawing. The problem is of assembly drawing of lathe tool post. Now what is lathe tool post? A lathe tool post is an assembly used in lathe machine to hold the cutting tool. So in order to hold the cutting tool which is used to perform different cutting operations, the assembly that is used is nothing but the lathe tool post. Now the assembly of the lathe tool post consists of the parts such as the post, block, ring, wedge and screw. So here the assembly has total 5 parts, that is post, block, ring, wedge and screw. Now we will see the actual assembly of the lathe tool post. So this is the assembly of the lathe tool post where all the parts mentioned earlier are shown. The first part which is at the bottom is the block. Now block fits inside the channel of the compound rest of the lathe machine. So in order to fit the entire assembly on the lathe machine, we insert the block inside the compound rest of the lathe machine so that it gets firm on the lathe machine. The second part you can see is a circular ring. This is the circular ring. Now the circular ring has a spherical groove inside it. You can see there is a spherical groove inside the circular ring. The third part is the wedge. This part is the wedge. Now the wedge is resting inside the ring. Now since the ring is having spherical groove inside it, the lower part of the wedge will also be spherical in shape. Now why this spherical groove is provided or why the lower part of the wedge is spherical in shape? First of all, the cutting tool which is to be fixed is inserted inside the post. Okay, first we will see the part. Third was the wedge. Fourth part is the post. It is cylindrical in shape. The vertical part, this part is nothing but the post. The lower half is completely cylindrical, that is from here to the bottom, whereas the upper part is tapered. The fifth part is the screw. Now screw is inserted inside the post. For having or inserting the screw inside the post, we have internal threading which is performed inside the post. So there is internal threading present inside the post and the screw will be inserted from the top. Now the actual cutting tool is placed inside the post. That is, a slot is provided. You can see this slot. This is a slot. This slot is provided so that we can insert the cutting tool inside this. So cutting tool is placed inside this the post. When we insert the cutting tool inside the post from this hole, it will rest on the wedge. So this surface of the wedge is used to provide a resting surface for the cutting tool. So when we insert the cutting tool, it will rest on this surface. Now in order to hold the cutting tool, we will use this screw. For example, after inserting the cutting tool, we will move the screw in clockwise direction or anti-clockwise direction so as to loose or tighten the cutting tool. If we tighten the screw, then this lower part will get in contact with the upper part of the cutting tool so that we can clamp the cutting tool inside this slot. So in order to hold the cutting tool, we use this screw. Now the question was why this spherical groove is provided inside the ring. The reason for the spherical groove is that if we uh, in current situation, if I insert the cutting tool inside this slot, it will be in straight position. But if you want to change the angle of the cutting tool, that is if it has to be tilted, it is not parallel to the base, that is if it has to be tilted at any other angle, then we will move this wedge inside the ring. So if we move this wedge inside the ring, what will happen, this will not be flat now, this it will be at some orientation because this groove is what spherical. So in order to move the wedge in a particular angle, a spherical groove is provided. And finally the tool which is resting on this wedge will also be inclined at some angle. So in order to move the cutting tool at a particular angle with respect to horizontal, the spherical groove is provided inside the ring. And similarly the spherical bottom part of the wedge is also spherical so that it can slide inside this spherical groove, and the tip of the cutting tool can be inclined at any angle with respect to the horizontal. So these were basically the 5 parts of the lathe tool post assembly. Now in this way question we have to draw the sectional front view and the top view of this entire assembly. Now we will see the question. Now you can see here the question. The first part, total there were 5 parts. The first part is the post. It is mentioned here clearly, post. Now the post is made up of cast iron and its quantity is 1. The second part is the block. Now it is a square block as visible from the figure. This is a square block. You can see it is not cylindrical in shape. It is what? Square. So the second part is nothing but the block. It is square in shape of square of side 90 mm and it is having a hole inside it. The third part is the circular ring. This is a circular ring. Again it is made up of cast iron and its quantity is 1. Now the circular ring is having spherical groove inside it. As you have seen, there was a spherical groove. This is a spherical groove inside the ring. So this is nothing but the spherical groove which is present inside the ring. So this is the spherical groove and it has a radius of 144. So the spherical groove is having a radius of R144. So this is the sectional front view of the ring. This is the top view of the ring and the ring is present in one quantity made up of cast iron. The fourth part is the wedge. This is the wedge. Now over the wedge we will place the cutting tool. So in order to place the cutting tool we use the wedge and the wedge can be tilted at any angle, so that cutting tool can also be tilted at any angle with respect to the horizontal. Now again the lower part of the wedge will be spherical in shape, so that this lower part will fit inside the spherical groove of the ring and it will have the same radius as R144, since the groove here was having radius as R144 and the length of the wedge is nothing but equal to 144. Again the wedge is made up of mild steel and its quantity is 1. The fifth part, that is the screw. The screw was used to hold the cutting tool in its position. That is, if we turn or tight the screw, then it will clamp the cutting tool inside this slot. We will insert the cutting tool here. So this screw will be inserted inside the post. See here we can see internal threading has been performed inside the post. So this internal threading is provided so that we can insert this screw thread which is having external threading on it inside it, and when we will insert from the top it will hold the cutting tool which will be located here somewhere in its position. So the cut screw will be used to hold the cutting tool in a required position. Again the screw, the fifth part, is made up of cast iron and its quantity is 1. Now we will see the dimensions of the post. Now you can see here the dimension of the post. The total height of the post is equal to 36. You can see here this is 36 plus 132 plus 12. So the total height will be equal to 36 plus 132, that is 168. 168 plus 12, 180. So the total height of the post will be 180. Now the bottom diameter of the entire post is what? Cylindrical in shape. Only the top portion of height 36 mm, that is from here to here, that is the upper part, will be tapered, whereas the entire remaining portion is cylindrical. Now we will see the dimensions of the post one by one. You can see the lower part is of diameter 72 mm. So this lower part is of diameter 72 mm. The cylindrical part will be of length of height 12 plus 132, whereas this upper part of height 36 mm from here to here is tapered. The top diameter is equal to 48 mm. Now the internal threading which is present inside the post is given of M18. M means the metric thread. This is metric thread of major diameter as 18. Now for a thread we always take the major diameter and minor diameter, but here the pitch is not given, so we will assume the minor diameter equal to 16 mm, that is major diameter will be equal to 18 and the inside diameter or the root diameter or the minor diameter will be equal to 16 mm. The diameter of this portion, that is this part from here to here, is equal to 60 mm. Now you can see we have taken the half section of the post. So in half section this part is solid, so we have shown the section lines, whereas in this part we have not shown the section lines. So since this is half section, This internal threading will not be visible on the right hand side, whereas in the section part this threading will be visible. And since this is a slot or a hole, this will be visible in section and in without section also. Now the length of the slot is equal to 24 mm. You can see the length of the slot is equal to 24 mm, because in this slot we will insert the wedge. Now you can see the top view of the wedge. The top view of the wedge is given as the width is 24 mm, so this wedge will fit inside this slot. In assembly we have to match the dimensions and see which part will insert inside the other part. So since here the dimension is given as 24 mm, the length, the wedge which is of width 24 will be inserted inside this slot, and over this wedge, that is over this rectangular surface, we will place the cutting tool. Now the top view, of course this part is cylindrical in shape, so the top view will be circles. So this outer circle will be of diameter 72 mm. This second circle which is visible will be of diameter 60 mm, whereas the third circle, this circle will also visible, so it will be of diameter 48 mm. So three diameter circles are visible: 548, 560 and 572 when observed from the top. Now this slot will not be visible from the top view, so it is shown as hidden. You can see these hidden lines. Now this slot is present inside which part? Inside the cylindrical part of diameter 60 mm. So this slot is shown inside the circle of diameter 60 mm only. You can see this slot is shown over this circle only, not till the outer circle. And since it is hidden, it is shown in dotted lines. Now this thread, now the threading, this is what internal threading. So for internal threading, the internal or the root diameter is shown as complete dark circle, whereas the major diameter will be shown with the help of 3/4 circle, which will be hidden. For internal threading we use a symbol, that is the internal circle or the minor diameter circle will be a complete circle which is visible, so it is shown as a dark circle, whereas the major diameter which is not visible from the top view will be shown with the help of a dotted circle which is 3/4, but it is not shown here. We have to show in the assembly diagram. Now the next part we will see the ring. Now the ring or the diameter of the ring is equal to 120 mm. You can see the top view, the distance from here to here will be equal to 120 mm. Since in the top view you can see the diameter is given as 120 mm. Now the ring is having a hole inside it. This is the hole, and the diameter of this hole will be equal to 60 mm, whereas it is having a spherical counter or spherical groove inside it over the top portion, and the radius of this groove is equal to 144. Now why this hole, that is the hole of diameter 60 mm, is provided inside the ring? Now this ring will be inserted inside the post, or the post will pass through the ring. Now you can see here the diameter is given as 60 mm from here to here, and this diameter is also given as 60 mm. So we will insert this ring from the top of the post so that it will pass through the post. You can see from this figure, this ring is inserted inside the, or the post is inserted inside the ring. So we will insert the ring from the top, it will pass through the post, and since the outer diameter of this part is equal to 60 mm, the hole inside the ring will also be equal to 60 mm. So the same hole is provided here, 60 mm, and the height of the ring is equal to 18 mm. Now the next part, that is the block. Now this block or the post will be inserted through the block. Now you can see the block is having a hole of diameter 60 mm. First we will see the block is a square block. This is a square shape, and then the square is of side 90. It is written here as SQ90, means the square is of side 90 mm. Now this square block is having two holes inside it. The first hole, that is this upper hole from here to here, is of diameter 60 mm, and it is visible from the top, so it is drawn as a dark circle which is of diameter 60 mm, whereas the bottom circle or the bottom hole which is of diameter 74 mm will not be visible from the top. This diameter hole, that is a hole of diameter 74, will not be visible from the top view, so it is shown as dotted circle. Now why this hole of 60 mm diameter is provided? We have to insert this post inside this block. So here the diameter of this part, which is equal to 60 mm, has to go inside the block. So a hole of 60 mm is provided inside the block. And finally this block will be inserted inside the carriage of the lathe tool post for holding of the entire assembly. Now the fourth part, that is the wedge. The use of the wedge was explained. Wedge is having spherical groove over the bottom so that it can easily slide over the spherical groove of the ring, so that the cutting tool can be positioned at different angles. And the top view of this wedge is a rectangle. The length of the wedge is 144. The width from the top view is 24 mm, so that this wedge will be inserted inside this slot, which is of 24 mm. And the height of the wedge is not known. Only this part is given as 6 mm, but the total height is not known. And the fifth part, that is the last part, screw, which is used for holding the cutting tool in the required position, is shown here. Again, it is a metric screw having major diameter as 18. Here you can see the major diameter was 18, so here also the major diameter will be 18, whereas the root diameter or the minor diameter, that is from here to here, this is the major diameter from here to here, whereas the minor diameter is from here to here, will be of diameter 16 mm. We will assume the minor diameter as 16 mm. See that here the pitch is not given. The head of the screw is consists of two parts. For the first part is cylindrical in shape. This is for resting. This part or this cylindrical uh, part will rest over the lathe to over the post. When we will insert this screw here, the threaded part, that is from here to here, will go inside the post, but this upper part will rest on this surface. Now the diameter of the upper part, which will rest on the top of the lathe pull post or the post, is given as 36 mm. So this part is having diameter as 36 mm, whereas the top or the head of the screw is not a cylindrical part, it is square in shape. It is here given SQ. SQ means what? Square. Square of side 18. So this upper head will be a rectangular block or square block of side 18 mm, and its surface will be chamfered. You can see here a curve is drawn. This curve is nothing but the chamfer circle or the front view of the chamfer circle. Now the total height of the screw is equal to 15, the upper part, plus 6, this, plus 72 plus 6. So if we add all the dimension, we will get the total height as 15 plus 6, 21, 21 plus 72, 93, 93 plus 6, 99. So total height of the screw is 99. But the lower part, that is of height 72 plus 6, that is 78, will go inside the post, whereas the upper part of height 21 will remain outside the post. This is the tolerance chart. You can see 60 h7, 24 h7. This is the tolerance for the hole of diameter 60 mm, 24 mm, and this is the tolerance chart for the shaft of diameter 60 mm and 24 mm. Now these symbols, that is a triangle shown here, indicate the surface finish of the surfaces. Now you can see here that on this surface only two triangles are shown, whereas on this surface also two triangles are shown, whereas on this surface three triangles are shown. Means what? This surface or the curved surface of this part should have more surface finish than these parts. So wherever more triangles are indicated, it means that that surface, that is this type of surface, should have more surface finish or more surface accuracy. In the next lecture, we will start with the assembly drawing of the lathe tool post. Thank you.